Okay, this lecture is going to take a look at what we call ions and isotopes. So before we get into that, I want to do a little bit of review. Parts of an atom. So we have three main parts of an atom. First, the protons. They're located in the nucleus. They determine the identity of the atom, meaning which element is it. They have a positive charge, and they have a mass of about 1 AMU. They're very heavy in comparison to other parts of the atom. The neutrons then are also located in the nucleus. They determine the mass of the atom. They have a neutral charge, and they also have a mass of about 1 AMU, so they're also heavy. The electrons are located in the electron cloud, or the orbitals. They determine the charge of the atom. They have a negative charge. They have a mass of about 0 AMU, which means they are very light in terms when we compare them to protons and neutrons. Mass of an atom is determined by adding the protons and the neutrons, so the number of protons and the number of neutrons together equals our mass of our atom. Last little bit of review here. When we're looking at the periodic table, we might see boxes like these. The atomic number, so for carbon, the atomic number is 6. It's located up in that upper left corner. It's possible that it will be located somewhere else on the box, but just being aware that that's what we call that, the atomic number. The mass then, or the mass number, is this number here, 12.011. On here, this is actually what we call the average atomic mass, and it's the average mass of all the carbon atoms in the world. So notice it's not exactly 12, and that's what kind of we'll get into today. How can it be not a whole number when we're adding just protons and neutrons together? Notice that the mass can be located in different spots on the picture. So here it's in the upper right, here it's underneath the name of the element. The element symbol or name, that's the C and the carbon. And so that tells us what element it is. Now, if we were only given the atomic number, we would be able to figure out that that was C carbon, because an atom with an atomic number 6 is carbon, no other atom. So now that we have that review, let's take a look at what are ions. Ions are atoms that have a charge from gaining or losing electrons. So if you remember, protons have a positive charge and electrons have a negative charge. So when the number of protons and the number of electrons equal each other, we have a neutral charge, or a charge of 0. But when they don't equal each other, that's when a charge comes in. We cannot gain or lose protons to form an ion, because if we gain or lose protons, we change the identity of our atom. Okay, so if we started with 6 protons and we had carbon, as soon as we lose a proton, we no longer have carbon, because now we have 5 protons. So an example, if we have a carbon atom with 4 electrons, what is the charge? So we know carbon has 6 protons, its atomic number is 6. Protons have a positive charge, so I'm going to write plus 6, and then I'm going to add to that the negative 4. Now, why negative 4? We have 4 electrons. Electrons have a negative 4, so each of those electrons has a negative charge to it. So I do the negative 4. If I have a positive 6 plus a negative 4, that gives me an overall positive 2. Okay, so my charge on my carbon here is a plus 2, and how we would show that is we would have the C plus 2 as a superscript there, as an exponent, showing that this carbon atom has a plus 2 charge. Now, isotopes are a little different. Isotopes are atoms of the same element that might have a different mass. Now remember, the only subatomic particles that have mass are protons and neutrons, which means since we cannot change protons if we want the same atom, the only thing we can change there is neutrons. So the only way for this to occur is for neutrons to change. So for example, this is a little different way of writing things, so I want you to take a look at this. This C here tells us that it's carbon. That's the element symbol. The 6 down here then is the atomic number. Okay, atomic number for carbon is 6. And the 12 is the atomic mass. Okay, so when we're trying to get information out of this, we know that the atomic number is equal to the number of protons, and then the mass is equal to the number of protons plus the number of neutrons. Okay, so in this one, the mass is 12, the number of protons is 6, and then I simply subtract to figure out how many neutrons I have. Now I have two more examples here. I have carbon, what we call carbon 13, because now we have carbon with a mass of 13. We have carbon with a mass of 14. So we're going to figure out how many protons, neutrons, and what the mass is, how many protons and how many neutrons. I want you to pause for a second and see if you can figure that out, and then I'll give you the answer. Okay, hopefully you paused and you did that on your own. So for this one, carbon with a mass of 13, mass is 13, still have 6 protons, because notice it's still carbon across the board, but now my neutrons are 7, okay? This one, carbon 14, still have 6 protons, still carbon, but now I have 8 neutrons. Okay, so notice here, I'm not worrying about how many electrons I have because there's no charge up here on any of these. I would just assume that it is neutral. So 2 things to remember. If you're not given a charge, like in those ones right before, you're going to assume that they are neutral, which means the number of protons equals the number of electrons. If you're not given a specific mass, you're going to use the rounded mass off the periodic table. Okay, so if you to look at here for practice, notice I have ones written in different ways. These are straight off the periodic table. These are in that other format that I just showed you. I want you to take a second, try these out, and then I will flash up the answers here for you to check out. Okay, so here are your answers. We're going to talk through this. Iron here, atomic number is up on the top. It is 26. That tells us our number of protons. Our number of neutrons then is our mass minus our number of protons. Now our mass, I didn't give you a specific rounded mass, so we need to round that. 55.845 rounds to 56. If I do 56 minus 26, I get 30. Now this iron does not tell me a charge either, so I'm going to assume that it's neutral, which means my protons are equal to my electrons. This aluminum, 13 is my atomic number, so that tells me the number of protons. I also don't see a charge, so my electrons are equal to my protons. My mass here is not rounded, so I'm going to round it off to 27. 27 minus 13 is 14. Here, Mg, that's magnesium. Remember, this is a little different. 12 now is my atomic number, so that's how many protons I have. 25 is my mass, so 25 minus 12 is 13 for my number of neutrons. And then I see that I have a +1 charge. So if I'm thinking back to that equation, a +1 charge means that I have one more positive thing than I do negative. Okay, my protons are my positive thing, my electrons are my negative thing. So if I have one more positive, I have one more proton than I do electron, which means if I have 12 protons, I have to have one less electron, which would be 11. Moving over this nitrogen, my proton is 7 because that's my number, or that's my atomic number. 14 is my mass, which means that I have 7 neutrons. Now my charge is -3, so that means I have 3 more negative things than I do positive things. So what that tells me is that I have 3 more electrons than I do protons. Since I have 7 protons, I must have 10 electrons. Now this nitrogen does not tell me a charge, so that means I determine my protons are 7 based on that atomic number, and my electrons are going to be 7 as well because it is neutral. They have to equal each other out. Now my mass is now 16. 16 minus 7 is 9, which is where my neutrons are. If you have any questions on this, make sure you are asking your teacher, but that is kind of how we determine ions and isotopes. Make sure from this that you understand not only how to determine protons, neutrons, and electrons of ions and isotopes, but you also understand the definition of an ion and of an isotope.